Hello, I'm Rafid, and in this module, I'll talk about the Chisel manifest. Chisel is able to generate a manifest that contains metadata about the files it has installed in the Chisel root file system, the pages it has fetched from, and the slices it has installed in the file system as well. Now, the way Chisel does it is in one of those slices that Chisel has to install, if there is a path of this kind, the generate manifest kind, Chisel generates a manifest file in this location here. The manifest file is named manifest.wall and it's produced in this directory here. This path is actually set to default location of varlib chisel in the base files underscore chisel slice. So if we were to install a chisel root file system and we did need a manifest generated at that location, what we'd do is would install the slices we need to install along with the base files underscore chisel slice. And installing the base files underscore chisel slice would generate a manifest, this location here. So let's see that. Now I have, okay, let's clean the repo files and put in repo files folder. What I want to do is I want to chisel cut. I'm on a 2404 machine, so I will be using the 2404 Chisel release. That's why I don't need to pass it as just release flag here. Now I want to install the OpenSSL bin slice and have my root file system ready to run OpenSSL. What I also want to pass here is the base files Chisel slice so that I get a manifest ready at that location there. Now it's releases, process it, and then look for any path in these slices and their dependencies that has the generate manifest kind. Now the base files Chisel slice has it, so it will generate a manifest at this location here. So as you can see in this log, it did generate a manifest here, and if I do find it first, I'll see that it has a bunch of libraries, OpenSSL binaries, and we do have the varlib chisel manifest.wall file as well. Now the manifest file is a JSD compressed file, and we can verify that with the file command. So it's a JSD compressed data file, and we could uncompress it to see what's there inside. So if I take a look at the manifest file here, we have a bunch of JSON objects, one per each line. This format is called the JSON wall format, and it's introduced in Chisel to support the manifest writing. In this format, every line is a JSON object, and the first line is a JSON object that contains metadata information about the type of this file. So we have the JSON wall header here. It's called the header, and in the JSON wall header, it specifies what version of JSON wall we're using, what's the schema for our application, and how many objects we have in total in this manifest file. It shows we have 122 lines. That's true. We have 122 lines. And in the Chisel manifest, we do have a few kinds of objects here, and we differentiate them by these fields here, the kind fields. We have the kind content, kind package, kind path, and then at the bottom there, the kind slice. Now, in the JSON wall file format, except for the JSON wall header, every other line is actually sorted alphabetically. So in any way the Chisel writes this manifest, it will be sorted for better comparison. I'll talk a little bit about the kind of objects we have, starting with the kind package. Now, the kind package specifies what packages Chisel has installed in the root file system. We installed the OpenSSL bin slice and the base files Chisel slice. So here we have the base files package, a libsys6 package, libsSL3 package, and the OpenSSL package installed. These two packages are likely installed because they're a dependency of the OpenSSL package. Now, for package info, we do have a few fields here. We have the version field that shows the package version, and we have the hash in the SHA-256 field. and the architecture indicates which architecture this package is intended for. Now, after packages, we do have a list of slices that has been installed in this root file system. Those are specified by kind slice and only has another field called name that says which slices are installed. So here we have the base files chisel, base files copyright, base files lib, and base files var slice installed from the base files package, and then a bunch of libc6 slices, a few libsl3 slices, and then we have the OpenSL slices installed here. Now we do have a list of paths that Chisel has installed in this root file system, and they're specified by kind paths specified here. Now, this is probably the most important bit of information that we will be using when we use this manifest for other purposes, that what files are there. Well, this is the type that shows that, and this type of objects could have different fields depending on the file type. Now, what's mandatory field here is the path field that says which file is installed in this Chisel root file system. So here, this etcssl such directory is installed with a mode of 755, and directory comes from the slices, the OpenSL config slices. The path could come from multiple slices, and the Chisel manifest would indicate so that there's a better ownership and accountability of paths. Now, this is a directory kind of path, and we can have a regular path as well. So this is a regular path that's installing the OpenSL configuration file. It has the 644 mode, and then it has a hash of this value here. Then finally, it has a size of 12324 bytes. The size field is indicated in bytes. And then we can also have a few mutated files that Chisel has mutated. And in those cases, there would be a final SHA here, along with this SHA. The SHA field contains the original hash of that file, whereas the final SHA would contain the mutated file hash. I'll show an example of that later. Now, we can also have a few different type of files as well. Besides directories and regular files, we also have links. So for symlinks, we have the path, mode, which slices it comes from, and then we have a link target, which means this symlink /lib actually points to user lib. And that's all for kind path. And then finally, we have another kind which also indicates the files that are installed, but it produces a relationship between slice and path so that it shows which slice produced which path. Of course, we have a relationship in the kind paths objects where for each path we list which slice this path came from. The kind content can be categorized as a reverse map of that. In here, for each slice, we have a path, and what this conveys is that the base files Chisel install the variable Chisel manifest.wall path and so on. So what this helps with is whenever we want to use the Chisel manifest later on to look for maybe like the OpenSL bin slice, what files did it produce? What it could do is just start from here in this line and just produce these two lines, and we'll see that this OpenSL bin slice has produced only two paths, and those are the CD hash binaries and the OpenSL binaries. Now, that's all there is to the Chisel manifest. And I'll show an example of the final SHA. The CA certificates data slice does have mutation scripts that I demonstrate. So let's do, and this time I'll install the CA certificates data slice along with the base files Chisel slice. Now this would install the CA certificates data slice along with the manifest located in the Firebase Chisel manifest directory inside the root of S directory. So it's installing. Alright, it has a manifest at this location here, and let's decompress it. Let's name it manifest2. And here, the package, we'll have the base files package, the libc6, libsol 3, and libsol. Sorry, I have produced the rootfs1. I want to do the rootfs2 one. Yes. So if I go to the manifest2 now, this comes from this CS certificates one. If I go to the package, then I have base files and CS certificates and OpenSL here. Now for final SHA, in this part here, it is CSSL CS certificates.crt file. It's a mutated file. So for this file, I have the modes and then slices, and then we have the SHA-256, that is the original hash of that file. And then in this field, the final SHA-256, this is after the mutation scripts have run and the file has been changed. This hash indicates the current state of that file. And then we have the size here. So if final SHA is not present, that means that file is not mutated and the SHA field contains the current hash of that file. Otherwise, the final SHA-256 contains the current hash of the file. Right. Now, we can do a bunch of stuff with the Chisel manifest. As far as Chisel goes, it only produces the manifest and completes its execution. Now, we can produce some third-party tools or some customary tools that can inspect or maybe export this manifest type to something that other popular vulnerability scanners or SBOM inspectors can recognize. In fact, we do have a project right now that our team is working on to produce a tool, as an example, that can export the Chisel manifest to an SBOM. So this is an example tool that one of my teammates has produced that can convert the Chisel manifest file to an SBOM file that other tools can hopefully recognize.